Hey everyone, welcome back to another video. Today we want to talk about trigonometry correlations. So let's start right into it. So we know that sinus of x is equal to the opposite side divided by the hypotenuse, cosinus of x is equal to the adjacent side divided by the hypotenuse, and tangents of x equal to the opposite side divided by the adjacent. Be careful, you could write as well instead of x, maybe I should do this, theta. Theta is just like the degree which you get. One of the biggest correlation is this one. So you got theta, so your degree is equal to the inverse function of sinus. So sinus minus 1 is nothing, and this is nothing else. You have to plug in opposite side divided by the hypotenuse for sinus, and for cosinus logically the adjacent side divided by the hypotenuse. This is extremely important because if you just have your opposite side, for example, in your hypotenuse, but you need the degree, for example in this case, let's say you've got this and this, of course you could say this, but you don't have the degree, so you're searching this, so the degree of theta. If you have this value or this value, or this value and this value, or because of tangents, but we're going to talk about this later, this value and this value, you can get this angle. Of course, if you change, for example, your theta, let's go away with this, and let's say this is your theta, those sides will change. So this will still be the hypotenuse, but this now will be the adjacent side, and this will be the opposite side, of course. So you can get any angle theta if you have like two of these sides. Why is this important? Especially for physics, this is extremely important. You will see this pretty often, so it's extremely important to understand this, and I'm going to do a video about this in my series Let's Learn Physics Together. But I just want to point out because I think this is quite nice to know. So let's say we have a two-dimensional space, or R2 space, and let's have a look at vectors in the space. So imagine you want to walk to a certain point x, okay? And let's say this is your favorite park. So this is your park. You know, to get there you have to walk 10 meters in the north. Okay, 10 meters is maybe a bit bad. Let's say 10 kilometers or something like this, but just for the idea, 10 meters, to the north, and 10 meters then to the east. So both of those things, so let's say 10 meters to north, and then after you walk 10 meters to the north, then 10 meters to the east. Okay, so those are vectors because if you add them together, what I did here, for example, so every vector of this, so this is your x value, so this is your x value and this is your y value, because north, let's remember, this is north, this is east, so north is your y-axis in this case, and east is your x, thing, your x values, I'm sorry, you get for your vectors. If you want to walk 10 meters east, you walk here, and then 10 meters north, you get this vector which you already see. The question is now in which direction would you have to go if you want to go straight from this point to this point. And spoiler, we talked about trigonometry, and look at this. This is a right angle, so 90 degrees. This means if we would have this is nothing else than the hypotenuse, right? And with this we can do a lot of nice things. So first the direction. So the direction means the angle. So if we have to go from here to here, we need a certain direction, a certain angle. And if we want to know how long we have to walk, we need another idea of a right angle triangle. So we need the angel. Let's have a look to this again. If we have this information, we know the 10 meters to the north will be our y value. So here, let's call this, let's say y, or let's stick with opposite, so O equals to 10. And we know that our adjacent side, or our x, will be, so our adjacent side will be also equal to 10 meters. Now we can do nice things. The first thing is, if we want to know our direction and how long we have to walk, we could do the first possibility, which is a bit more work. So you could try to calculate this, which is nothing else than, remember, a squared plus b squared equals to c squared. This is like from Pythagoras. And this means we just would make this, so 100, so 200 would be equal to c. I'm sorry, so 10 squared plus 10 squared, so this is clear, equals to c squared. C, I'm sorry, in this case h, it's getting late again, I'm sorry. So I wrote this down here already, don't know why I did it, yeah. So with this, we could actually then try to calculate our angel theta, since we know sinus, so our angel theta is nothing else than sinus, and we just plug in the opposite side, and now we have the hypotenuse, because h is nothing else than the hypotenuse. So we could just plug this in, those values. So this is that. To understand how long, so this step we do have to do nonetheless if we want to know how long do we have to walk or how the distance is. But for the angel, if we just want to have the angel theta, the angle, did I said angel? Oh my god, I'm stupid. I mean, if we just want to have the angle theta, we just can use just the tangents, yeah. And then we just use the reverse thing. Yeah, this is basically the thing. I'm sorry, did I say angel? Oh my god, yeah. It's the beginning. All beginning is hard. See ya.